AVL is a large company based in Austria with worldwide subsidiaries, which is in the automotive business with engineering, testing solutions, and simulation tools. And this is also, of course, our focus in the project. Now, let's switch to Insect. Insect is a large European project which started in 2020 and will end August of this year with 40 plus partners all over Europe. And I guess the best way to learn a little bit about the project would be just to go on the website. You can see the address on the top slide, www.insect.eu, insect with double T. And the motto you can see already on the screen, going to the edge, bringing the Internet of Things and artificial intelligence together. So that's the main thing about it. So Insect, the name, and why is there the double T? Well, you see those words on the left side. It's about intelligent, secure, trustable things. Intelligent, well, we see more and more systems, devices, gadgets getting more than just standard basic features, getting something like intelligent. And making something intelligent often is combined with AI, ML, and this is often combined with data, and often data comes from IoT systems, from the environment. Data needs to be secure, systems need to be secure. So this is a very, very big focus of our project. And together with that, it's also about trustability. So when is a system trustable? When is an AI system trustable? This is another thing we work on, both the basic principles as well the implementations. And it's about things, about actually many things in many different domains, industrial domains, where we apply those technologies which we develop in this project. Okay, and this is the main formula when we say we bring together artificial intelligence, AI, and IoT. Then we say it's a new thing and it's more than just the sum of the parts of it. It's the artificial intelligence of things, AIoT. All right, so artificial intelligence of things. This is something we think is quite natural when the IoT devices get more and more AI either embedded in the system or in combination with something working on the cloud. So both is possible. Why is that? Well, very, very clearly, AI increases the value of IoT, and it does so through making things, well, adapting to the environment, using data from the IoT systems. So it's a mutual benefit between AI and IoT. And AI very often runs in the cloud. We see that, and like ChatGPT, for example, is now more or less well known to everybody. But there are many reasons why AI should also run, or maybe even just run, close to the IoT system, close to the device. So on the edge, for example, to process data locally makes a lot of sense if this is critical data, time critical, but also GDPR critical data. And to a lot of solutions just work that way. Okay, so the idea is that we provide methods, provide technologies, implementations, mature technologies. So those things can get trustworthy. They earn the trust of the users. And we did a deep analysis on what is trust and how is it, how can trust be achieved in systems, and then how can we implement that in AIoT systems. Part of it would be also resiliency, security, reliability. And security and how to test security is also a very important thing in this project. So it's about AI supported in embedded processing, as well as AI in wireless transmission, as well as also, at least partly, AI in cloud systems. We worked on a high-level architecture, which was published and which is an extension of industry standard architectures, as well as an extension of a previous project, which is called SCAT. And unfortunately, I don't have the time to go into details, but we worked on where and how to add the aspect of artificial intelligence in these typical industrial high-level architectures. So there's something to be read on that. Finally, the use cases. So a very important part of the project is that these ideas, these technologies need to be driven by use cases, real-world use cases, industrial use cases. And as you can see, within a lot of domains in the automotive business, where my company comes from, as well as in public transport, in smart infrastructure, aeronautics, airplanes, in public health, manufacturing, of course, a very big sector, smart building, as well as maritime and railway systems. Now, let me give you a very short example of what we do, and then actually this is a nice collaboration between ISEP and AVL. And it's about the connected vehicle. So vehicles already do, and in future will even more so do, communicate between each other, as well as towards some base stations or some road infrastructure. And this works pretty okay in a free area and rural areas. However, as long as the coverage is given. However, it gets quite complicated in special areas like, for example, inner cities, between skyscrapers, within tunnels, and these kind of scenarios. It's very hard to simulate and to model this behavior, and also we work on aspects on how to overcome the challenges, for example, with MIMR systems, and to do so intelligently. Now that brings together all these base ingredients, and the cybersecurity topic is something which AVL, for example, follows in that quite deeply, and how to test those systems towards cybersecurity properties. So where is some specific outcomes of this use case, or from this technologies applied in this use case, is, for example, a better modeling methods, applying, for example, AI ML to make it much more performant, much better in a lot of ways. And most importantly, applicable, so we can use that models for not only simulate the behavior of existing systems, but to improve them, for example, by applying multiple input, multiple output systems towards that, and controlling and steering the communication much better. Well, I'm already at the end of my time slot, so let me come to the summary. Insect is about bringing together the IoT and the artificial intelligence, making it the benefits from both systems, merging them together into the AIoT, the artificial intelligence of things. Together with that, it is even, very important to build the trust in the AIoT, otherwise it will not get acceptance in the marketplace. So dependability, security, safety, and those properties are extremely important, and how to achieve them. And finally, we showcase that in a broad range of industrial applications and domains in a lot of use cases.